Ladies and gentlemen, we ask that you please take your seats at this time as the program will begin momentarily.
Research is a journey. And unlike an aircraft that flies directly from A to B, research does not follow a straight path. But thankfully, in the world of scientific research, there are clear waypoints that are there to avoid us getting lost. So let me take you on that journey. The starting point of every research journey is a problem. Typically, this is often a general problem, which can be studied from many different perspectives and is often too broad for one study or one discipline. That is why multidisciplinary research became popular. Another important thing to realize is that it's not your problem. It is the problem of the problem owner or your client. Your problem, or rather challenge or assignment, is distilled from this general problem into a research objective or mission statement that fits within your field of expertise and available resources within your research area. Let me illustrate this by an example. If the problem a local government puts on the table is that there is too much waste, then it's obvious that this is a problem. However, this problem does not tell you what to study or what the local municipality expects you to do. There are many different types of study possible that contribute to possible solutions or explanations for too much waste. You could look at why waste exists at all, or how to avoid the creation of waste in the first place, or how to reduce waste, by recycling for instance. All of these studies can contribute to solving the municipality's problem. By talking to the problem owner, you'll understand better what their needs are, and you can propose what type of study you could carry out to help them within your field of expertise. The next stop on our research journey is sample. The concept of sample may seem strange in many engineering challenges. If I'm designing a new car or house, I'm not sampling anything. If you take a closer look, you will see that that is not entirely true. A design doesn't magically get created out of nothing, does it? A sample is defined as a representative selection of units from your population of interest. What this means is that when you do research, you only include some of the objects you want to study in your study, because it's impossible to study everything. You take a sample. Yet, you must also include enough to ensure your sample is representative. Let me give you an example. Let's say you want to study the production quality of jelly beans, a type of candy that you bought a 10-kilogram bag of. Assume that the photo here shows all your jelly beans. What would be a suitable sample? If we were to take 9 jelly beans as shown here as a sample, that would likely be an unsuitable sample. They are simply too few in number. If we were to only look at orange jelly beans, our sample would also not be representative in color or flavor, with only orange colored and flavored jelly beans. We would need to test a sample such as shown here, that is sufficient in number and color and flavor variation. Now, coming back to the design of a car, what is your sample there? Here you have to take a step back. How do you know what requirements your design needs to meet, other than regulatory ones? And once your design is finished, how will you decide if your design is successful? In those cases, your sample may consist of a number of customer focus group outcomes to distill your design requirements, or to have your design evaluated as to its fit for purposeness by a group of peers, which will be a sample from your entire population of peers. This is also where design meets research. As designers, we often do not think in samples. We are creating after all. This is, however, not entirely true. Even when designing or creating, we sample to research our design, be it in terms of requirements, methods used, or verification. It is important we convince our client that what we will build will work. Our next stop on the journey is that of measurement. Now, in research methodologies, a much higher order definition of measurement is used than you may be used to. Measurements can be many things and are not always exact. In this course, measurement is defined as the process of observing and recording these observations that are collected as part of the research effort. What this means is that it's important to decide what you will and can measure. What are relevant measurements for your research? Can you record them? And are you able or allowed to? All things you must take into account in your research design. Let's for instance look at the efforts governments are trying to make in creating an app to trace who you've been in contact with. From a purely engineering perspective, you're just building a piece of code. But to build a piece of code that does the job, you must understand what variables to code, and how you or others measure these variables, and whether you are allowed to measure these in view of privacy. You must also find out where to store this data and how to safeguard these data. Once you know what type of measurements you want to do or work with, the next waypoint of a research journey comes into view. Design. This phase of research specifies how you will answer your research questions. It determines how deep you will go, which methods you will use, and how long it will take. In this phase, you structure your research into deliverables. Be mindful that design is an iterative process, and you may need to make changes to your design during your journey. After finalizing your design and carrying out your measurements, you'll arrive at the next station, analyze. This is where you prepare your data for analysis, by building your model, code or design, or by creating a data file for analysis. Typically, you will generate descriptive statistics, standard output or graphics of what the data shows, followed by an analysis of the outcome of the data, and often also by an analysis of the significance of the data. For instance, by using statistical analysis to test the research hypothesis of your research design. We are now approaching the end of our journey, the conclusions. This is where all the pieces of your research puzzle come together. You summarize your findings, you discuss the implications of your study, the results as well as its limitations. You also list what you could not answer or how your data cannot be interpreted. This then leads you to discussing any remaining problems and areas of further research, often phrased as recommendations. With this final step, you'll have completed your research journey.